Welcome to the class, my dear students. In today's lecture, I am going to do the problems on partial derivatives of three variables. Partial derivatives with the two variables in the previous a couple of lectures we have done it already. So in today's lecture, I am going to do with the three variables. So that means when you are differentiating with a function with the three variables means corresponding to the particular variable you are differentiating by keeping the other two variables as the constants. Let us illustrate some problems to solve this type of criterion problems now. Number one, that is, if the function f of x, y, z is given by, let us say, x cube plus y cube plus z cube is there. Now, find fx, fy, fz. So this is what the question. So now you are going to differentiate fx, that is dou f by dou x. So that is dou by dou x of the function x cube plus y cube plus z cube. Now you are differentiating with respect to x. So the constants are y cube and z cube. So the derivative of x cube becomes 3x square. The derivatives of y cube is 0 and z cube is 0. Hence the value of the partial derivative is 3x square. I hope it is clear. And similarly, f of y, if you want, it is dou f by dou y and is given by dou by dou y of x cube plus y cube plus z cube. Now you are differentiating with respect to y. So the constants are x cube and y cube. So the derivative of y cube becomes 3y square. This is what the derivative of the function with respect to y. Similarly, fz, if you want, that is dou f by dou z is given by dou by dou z of x cube plus y cube plus z cube. So you are differentiating with respect to z. Therefore, the constants are x cube and y cube, and hence the value of the z cube is 3z square. So this is what the way to find out the partial derivatives of the functions with respect to so and so variables. Let us now take one more problem to understand this concept of three variables partial derivatives. Let us take f of x, y, z is given by e raised to minus of x square plus y square plus z square is there, suppose. Now here you have to find out fx, that is dou f by dou x is given by dou by dou x of e raised to negative of x square plus y square plus z square. We know the chain rule. The e raised to f of x is given by e raised to f of x times of f dashed of x. So it is e raised to minus of x square plus y square plus z square times of, now the chain rule is dou by dou x of the inside function, which is x square plus y square plus z square. So you are differentiating with respect to x, right? So the y square and z square are the constants, and now this gives you e raised to minus of x square plus y square plus z square times of derivative of x square is 2x. So this is what your function. Next, similarly, you can guess what is fy, which is dou f by dou y, which is given by e raised to negative of x square plus y square plus z square times of, again the chain rule with respect to y, right? X square plus y square plus z square. Now the constants are x and z, that is x square and z square are the constants. So this you will be writing it as y square derivative is 2y times of e raised to negative of x square plus y square plus z square. I hope it is clear. Similarly, you can find out fz also, which is dou f by dou z. You can, instead of x, now the constants will be first we write down x square plus y square plus z square negative of this one times of dou by dou z of x square plus y square plus z square. So now the constants are here, x square and y square are the constants. So what we write here, that is e raised to negative of x square plus y square plus z square times of the derivative of z square is 2z. That's the solution. I hope it is clear. When the function is with three variables, how to solve, how to get the partial derivative. Another way, now for example, if you have another function as f of x, y, z as the x cube plus y cube plus z cube, the whole raised to 1 by 3, let us say. Then how to solve this problem? Let us now take this problem into the next this one. Let us go to the next page and solve this. So now the value of the function is, now we are differentiating with respect to x. So fx is what now? Dou by dou x of the whole function x cube plus y cube plus z cube, the power 1 by 3. So again we are using the chain rule. What is that? It is 1 by 3 times of x cube plus y cube plus z cube, the whole power 1 by 3 minus 1 multiplied by the chain rule, dou by dou x of x cube plus y cube plus z cube. So now that gives you 1 over 3 times of x cube plus y cube plus z cube to the power 1 over 3 minus 1 becomes minus 2 over 3, and the derivative of x cube becomes 3x square. So this is what your fx. Now you can start guessing and you do the problem as what is f of y. This first term will be as it is, right? The first term will be as it is, and only in this place you are writing differentiating with respect to y, and that becomes a 3y square. For z it is 3z square. That's the only change you can understand, and that is what you have to make it very clear while doing the problems. X cube plus y cube plus z cube to the power minus 2 by 3 times of 3y square. In the similar way, you can find out fz also as 1 over 3 times of x cube plus y cube plus z cube to the power minus 2 over 3 times of 3z square. Of course, you can simplify this. This 3 and this 3 gets cancelled. Here also 3 gets cancelled. Here also 3 gets cancelled. So this gives you just x square, and the power is minus 2 by 3. So I can write it as x cube plus y cube plus z cube, the whole power 2 by 3. The same way you can express this also as the whole thing, y square by this whole thing and z square by this one. Like this you can write down. I hope you could understand how to find out the partial derivatives of three variables when you use the product rule. We have used the chain rule now to do the problem. I hope it is clear. Thank you.